Welcome. Today I'm presenting Hermes, an agent-operated policy marketplace. Hermes moves the journey from eligibility to settlement away from opaque application backends and toward a trust minimized protocol. The goal is simple. Instead of asking users and auditors to trust the platform's internal record, we make important decisions which are signed, time-bounded, and independently verifiable. Let's first take a look at the journey. In most marketplaces, we move directly from user intent to payment. But for high-stake marketplace, that skips an important question. Why was the transaction allowed? Hermes separates the process into three stages. First, an agent establishes eligibility. Second, the decision is persisted as a verifiable evidence. And third, the settlement happens only after required protocol level checks pass. So the important transition is simply not from intent to payment, but it's from eligibility to evidence and later to settlement. The real problem which we are solving here is fragmented trust. Imagine an RWA issuer reviewing KYC information and eligibility conditions in a spreadsheet or private database. The issuer may tell a buyer that you are approved, but the buyer has no independent way to know whether the decision is still valid or whether the underlying policy change the records have been modified. Hermes changes that model. Instead of saying trust my records, the issuer can say query the protocol yes. This is the fundamental trust shift in Hermes. Our initial target is RWA providers that currently relies on manual eligibility checks and spreadsheets. The activation movement is simple. Instead of manual checking, the issuer can query a signed time-bound eligibility record and verify the state directly. Next, so why do we need Arkiv? A conventional database such as Postgres can store all this information, but important guarantees remain at the application level. For example, a created by field in normal database is simply a data stored in it. An administrator with sufficient privileges have right to modify it. With Arkiv, authorship is tied to protocol level verified signatures, and expiration is another important difference. In traditional system, we might depend on a cron job or backend process to mark a code as expired. Hermes uses entity expiration. The code has bounded lifetime, and after that lifetime, it is no longer available through the query surface. So, the expiration isn't simply the application claims happen. It becomes a protocol level guarantee. The core object in Hermes is eligibility code. Think of it as a signed contract between the decisioning agent and the settlement layer. The agent doesn't simply say the user is eligible. It provides a bounded signed code containing the information required for later verification. One particular important field is the rule hash snapshot. This pins the exact policy version that was used when the decision was made. That prevents policy drift. If the policy changes after the code is reissued, the settlement layer still knows exactly which version produced the original decision. So, eligibility isn't current Boolean. It's a evidence that is tied to a specific policy version and a specific time window. The architecture deliberately separates responsibilities. The agent decides, Arkiv stores and exposes the verifiable state, and the settlement layer verifies before allowing the final distribution. This separation narrows the trust boundary, and no single component is responsible for deciding or storing unilaterally finalizing the entire transaction. This platform can then therefore be replaced or audited without losing the underlying evidence. Not everything belongs on Arkiv. Raw PII and heavy private blocks remain off protocol. Hermes stores the minimum verifiable evidence and references. This keeps Arkiv focused on evidence rather than secrets or large payloads. Next, uh, let's move on to a data model. Our data model is built around four core entities. These entities represent the marketplace state required for eligibility, voting, revocation, and settlement. We deliberately use tight numeric attributes for values that claim home places. That's important because these aren't just things that we search, but they can participate in deterministic range queries. We also account for Arkiv's no join constraint. Since Arkiv doesn't support joins, Hermes doesn't depend on them. We use explicit identifiers such as listing ID and court ID to connect related entities. If a reference listing expires while a court remains active, the settlement part must treat that reference as a invalid rather than reconstructing the relationship to a database join. Now, let's move on to our inventory logic. So, the inventory logic is one of the most important parts of performance. We don't depend on mutable counter to determine availability. Instead, we perform a soft reservation check by evaluating the currently live eligibility codes. This allows the system to determine how much inventory has effectively been reserved without maintaining a single mutable inventory number. Then, at settlement, we perform a hard spend check against distribution receipts. These two layers serve different purposes. The quote layer represents temporary reservation, whereas the receipt layer represents actual settlement. Together, they provide a more auditable way to prevent overquoting as well as over-distribution. Now, let's move on. At the larger scale, the first concern is query selectivity, which is done before client-side evaluation rather than scanning the entire marketplace. Let's follow one eligibility decision. This process starts with a bounded quote. The decisioning agent evaluates the policy and creates assigned eligibility codes. The code has short lifetime of 5 minutes. That short TTL is intentional. An eligibility decision should not remain valid indefinitely when the underlying marketplace state can change infinitely. The result is signed approval that must be acted upon within a defined window. To keep on more on the logic, let's explain it with using a sequence diagram. The first is the decision loop. The agent evaluates the user against the policy and creates the assigned eligibility evidence. The second is the settlement loop. When the settlement is requested, the protocol state is checked before a distribution receipt can be created. More importantly, an auditor does not have to call a private platform API to reconstruct what happened. They can just query the public protocol state and independently follow the evidence. So move on from that. Let's view more detail on the settlement part. It is a protocol check and not a callback. Before settlement succeeds, we verify the eligibility word and verify that the code is still within its validity window and check whether a revocation entity exists. One day when these conditions pass, do we create the distribution receipt. This makes the settlement decision observable, and because the relevant evidence remains available as protocol state, the process can be independently inspected. This is where versus the trust gap. A user doesn't have to ask the platform to prove that they are eligible. A public client can query the protocol directly and inspect the relevant state. The browser can therefore communicate directly with Arkiv rather than entirely depending on a platform backend. This is the idea of data sovereignty in Hermes. So the user doesn't have to take our word for it. They can verify it themselves. Finally, Hermes explicitly models failure and control points. Policy versions are pinned so decisions cannot change silently. The codes are time bounded, so stale approvals don't remain valid indefinitely. The system also supports an agent kill switch for emergency control, and revocation is additive. We don't erase the original history. Instead, a new revocation entry records that an earlier authorization should no longer be found. This preserves an auditable history. To summarize, Hermes moves the source of truth from platform trust to protocol trust. We take an eligibility decision, bind it to a specific policy, and sign it, give it a bounded lifetime, and make the resulting state independently queryable. Settlement happens only after required protocol checks succeeds. The result is a tamper-resistant, transparent, and independently verifiable marketplace. Importantly, eligibility is no longer something the platform tells you. It is something that you can verify. Thank you.